So, hello everyone. I hope you all are fine. And today we are discussing the puzzle that I have given you in the Telegram group. So, I hope you have attempted that puzzle. And this is a solution video. And this is not only the solution, but it will also tell how to build the thought process. Okay, so let us start. So, our puzzle was this: the continuous penny game. So, what does this tell? So, this tells a row, okay, a row of n pennies is placed on a table. Okay, wait. No. A row of n pennies is placed on a table. Two players take turns. Okay, so there are some number of pennies. Let's say that is n. One on a turn, a player can remove either one, two, or three pennies. So a player is allowed to remove either one penny, or two pennies, or three pennies. Okay. But the main point is that the pennies removed must be adjacent. Like, he cannot do something like this. There are like n pennies. He cannot remove this penny and this penny. He can remove one block of two penny, one block of three pennies. Okay, you got it. And the next is removal must not create any space. Remember this, okay? Or gap in the remaining line of the penny. So what does that mean? This means that if there are n pennies, he cannot choose penny from any between. No, he can either choose any number of pennies, whether that be 1, 2, or 3, from this corner, or starting wait or starting from this corner. You understood? Okay, so now we has that the player who get the last penny wins. So we just need to find the winning strategy. So we need to find, does the first player have a winning strategy? Okay, and for which values of n does the first player has winning strategy, and what is that? So let us move on how to find that. So how we can do that? So see, there is one advice in this type of problems. Always try to see small cases. So let us start. First, let us consider if there are n is equal to wait. First, consider n is equal to 1. So there is only one penny, and player 1 will take that penny, and player 1 will win. Okay, so player 1 wins. Now let us do this for n is equal to 2. So there are two pennies, and now again player 1 can take these two pennies, and again player 2 can win, and same goes for 3. There are three pennies. Player 1 can again take the penny, and player 1 can win, right? But let us see what happens for n is equal to 4. So now for n is equal to 4, there are 4 pennies, right? And now we see that so what are the moves that player 1 can do? Player 1 can take this penny, But taking this, then player 2 can take this penny. Player 2 can take this penny and win. And if in this player 1 did this, I mean from the last also, if he did that is the same thing, similar. If take 2, then the player 2 will again take this and win. And if it does 3, then again player 2 takes and win. So we saw something good, right? We saw, what do we saw? We saw that at n is equal to 4, player 2 can force a win, right? So we want, okay, so player 2 can force a win. So now this can help us to find the winning strategy. So we want for how many values of n does, for what values of n does first player has the winning strategy. So if, let us consider one more case. Let's say n is equal to 5, right? So now I am seeing something that if there are 5 coins, what player 1 can do, it can take the first coin and make the 4 coins, and for this 4 coins, I am saying like this, for this 4 coin, who is the first player, I mean this stop, this will go, let's say this is not there, who will be the first player? This will be player 2 will become as our first player for this case. So who loses? The one who do first move will lose in this configuration. So who is doing the first move? Player 2. What does this imply? This implies that player 1 wins. So over here player 1 takes, and in this configuration player 1 force a win. And wait, what is this? Okay, wait, let me remove this first. Okay, yeah, it's now removed. That was a mistake, never mind. So where we were, so player 1 can force a win. So what does that mean? Now that means for n is equal to 6 and for n is equal to 7, same goes. In 6 player 1 will take 2, and in 7 player 1 will take 3 pennies. Okay, and the same 4 will come. Now we have got something good, that so player 1 can win, just can, wait, let me write this on the next slide. So over here player 1 can win if player 2 lands on 4 pennies and does the first turn for that set of 4 pennies. Okay, what does this means? Okay, so this means that, okay, let me add a new page. So this means let's say we have some pennies. If we can somehow force that player 2, after doing some cut and such, player 2 lands on 4 pennies and it takes the first penny out of this, then the player 1 can force a win. But how do we do that? So we can do this like this. So here some congruence modulo will come in. So if n, write it like this, if 4 divides n, that means if n is a multiple of 4, then player 2 can force a win by the following strategy. Now what is the strategy? So the strategy is that there are n coins. Let's say player 1 picks k coins, where k where k belongs to, k can what, k can be 1 or 2 or 3. Okay, you can do like this, that will be much better. Okay, see, no, sorry, actually this is not an interval, so you write like this. Yeah, so where k belongs to either 1 or 2 or 3, k can be 1, 2 or 3, then player 2 picks 4 minus k coins. What does this do? This will do that if let's say there are some coins, let's say that is 4k, and this is a multiple of 4. If the player 1 strikes out 1 coin, then player 2 will strike 3 coins. Why? That will again make the rest of the coin a multiple of 4. Multiple of 4. So at any end, this will come. This configuration will come, right? This configuration will come. You think like all the multiples of 4 are coming, like all the multiples that are less than and equal to 4k are coming. So 4 will also come, and at every multiple, who is picking the first, at every configuration like that, who is picking the first coin? Player 1. So who will force a win over here? Player 2 will force a win. So what do we get? We get that if n is a multiple of 4, player 2 can force a win. So this is our winning strategy. Now but if 4 does not divide n, that means n is not a multiple of 4. So what do we do? Who can force a win? So we see that just player 1 can force a win. Now here player 1 can force a win. Now how can he? Let us see. By the following strategy. Okay, so what is the strategy? So the strategy is very clear. If there are, let's say, some coins and these coins are, let's say this coin, let's, no, not like this, let's say after some any set of coin, let's say we can say that this n is of form 4k plus l, where l is equal to 1 comma 2 comma 3. L can be anything. So what does player 2 does, player 1 actually, sorry, take l coins. This is what player 1 do. Now player 2 goes first, player 2 goes first in the configuration where there are 4k coins. Here player 1 will force a win. Now you see how elegant this is, that if let's say this is a form of 4k plus 1, okay, this is a 4. So what do? You take, player 1 will take the first coin. Now this is just the same configuration that we have heard before, 4k coins. Now player 2 is doing here first and player 1 is doing here second. Player 1. So who wins in this configuration? The second, who do the second turn. So player 1 will force, and same goes for 4k plus 2, take 2, 4k plus 3, take 3. Okay, so this was our solution. I hope you got everything right, and this is how you can think of how to solve a problem. So this was like very intuitive problem, combinatorics, and this was game theory, like game theory puzzle. We will discuss this later in higher, after some time we will discuss what is game theory, etc., everything, winning strategy. But this was a basic puzzle, so minimum time it could have took you was something like max to max a day or 2 days, maybe, not more than that. Okay, not less than that, you took the time. So yes, this was our solution. I hope you enjoyed watching. So thank you for watching. Bye bye, we will meet again for the next puzzle. Thank you everyone.